Now, in the previous video, we have talked about the order ration and how it cannot be determined from your overall equation, and it must be determined from your experiments. Now, the order of reaction can actually be determined if you know the reaction mechanism and if you know the slow step. So example, there are two types of reactions. We could either have an elementary reaction, meaning a single step. Elementary means it's a single step. Or it could be non-elementary. If it's non-elementary, it will be multiple steps. Non-elementary means multiple steps. Okay, so for example, if it's a multi-step reaction, you have your overall equation 2a plus b giving you your products. It could be split up into two steps reaction, where the first step is a plus b giving you c plus x. And then the next step is a plus x giving you d. Okay, so the overall reaction is given by this. This will be your overall equation. From the slow step, we will be able to determine the order of reaction because the slow step is also known as a rate determining step. Okay, how fast your reaction proceeds is entirely governed by your slow step. Okay, so I give you an example. Let's say you are traveling in a car, okay, along a single road. Okay, along a single road, there are other cars over here. There are other cars in front of you. Okay, multiple cars in front of you. Now, they are trying to get from destination A to B. You need to understand that how fast you're able to get from A to B does not depend on the fastest car in front of you. Instead, it depends on the slowest car. The slowest car will determine how fast you are able to travel. So that's why we call that the slow step as the rate determining step. So based on the slow step, we can determine that your rate equation is equal to K, A, and B because there's only one molecule of A and one molecule of B in your slow step. So therefore, it will be first order with respect to A and first order with respect to B. If you are an elementary reaction, which means there's only a single step, your rate equation will be rate equals to Ka squared and B, because if it's only one step, this will be your slowest step. So it'll be rate A to the power of 2 because the coefficient is over here, and B to power of 1 because the coefficient of B is 1. Now let's look at how to deal with cases where your rate equation is in the second step, where your slow step is the second step. Okay, let's look at some other examples first. So for example, in this equation, this is the overall equation. Your slow step is in the first step. So therefore, your rate equation will definitely be rate equals to K, H2O2, and I minus, first order with respect to both. IO minus is an intermediate over here. Okay, it's an intermediate. Intermediates are short-lived species that do not appear in your overall equation. Over here, X is the intermediate. So once it is produced, it will immediately be used up. So it does not appear in your overall equation. So IO minus is your intermediate, it's not a catalyst. I minus is a catalyst over here. Reaction is first order with respect to I minus, yes, and first order with respect to H2O2. So all these are correct. So the one that is incorrect will be B. Now let's look at what happens if your slow step is in your second step. So based on this, your rate will be equals to K, B, X over here. Okay, this because based on the slow step, this will be first order with respect to B and first order with respect to X. But your X is your intermediate and should not appear in your rate equation. So therefore, we need to get rid of this. How to get rid of it? Okay, if the second step is the slow step, it means the first step is the fast step. And if it's a fast step, it will usually be a reversible reaction. So it's a reversible reaction. We can represent it with a Kc expression, equilibrium constant. So the first step can be rewritten as a Kc equals to X over product over reactants A, B. And therefore X will be equals to Kc A times B. Once you know this, you can replace this with the X. So this will be equals to K, Kc B times A times B. So if you simplify it, this will be the new rate constant K prime, B square A. And this is how you determine the rate equation where your second step is the slow step. This is 1 minute of chemistry. See you the next time.